In this video, we will be examining the Fulmatic PLC Library. When you visit our website at fultek.com.tr, you can access the dedicated page for this topic by clicking the PLC Library link under the PLC heading. The Fulmatic PLC Library has been developed to enable you to manufacture your own custom PLC devices. With this library, you can write your own firmware and produce PLCs using your proprietary PCB designs. The library is free to use for PLC code up to 2048 bytes. For higher capacity projects, you can manufacture by obtaining a license for $10 per PLC unit produced. To facilitate this, you must include a TSHA-204A integrated circuit in your circuit schematic. Once this component is added, you must license each CPU module produced via our licensing application. No additional licensing is required for the I/O modules connected to the CPU. The licensing process applies exclusively to the CPU. You can also visit our GitHub page to access our projects by clicking the provided link. Detailed documentation is available in the README section of the repository. The reference circuit schematic for a sample PLC is also accessible in this section. You can examine the complete open-source schematics for the microcontroller, Ethernet, serial port, analog input, analog output, digital input, and digital output circuits. The Fulmatic PLC Library allows you to design circuit schematics fully tailored to your specific requirements. In our GitHub example, the STM32F407 microcontroller was selected. The STM32 CubeMX tool is used to configure the I/O channels and peripheral definitions for the STM chip. If desired, you may also utilize different ARM-based microcontrollers. The current reference project is configured specifically for the F4 series microcontrollers. If you wish to use a different microcontroller, you can request the appropriately compiled version of the library for that hardware from us. Now, let's download the library to our computer. We download the file by selecting Download Zip from the Code menu on our GitHub page. Extract the downloaded file to a local folder. The extraction process is complete. We will use the Visual Studio Code editor to write our code. I will select the project folder we just extracted using the Open Folder option. The sample project has been successfully opened in VS Code. Let's examine the Main.c file located under the src directory. You can view the existing code structure within Main here. The sample code contains several guiding directives. By following these guidelines, you can structure your own code appropriately. Since this project was prepared with CubeMX, ensure your code is written between the user code begin and user code end tags. This ensures that your code is preserved when the project is regenerated via CubeMX. This allows you to continue your development seamlessly. Now, let's build the project we downloaded. The build is successful. There are no errors. Since my ST-Link configuration is already set up, I can switch directly to debug mode by pressing F5. We have established a connection with the chip and are now running in debug mode. Next, I will launch the FulmaticSoft software. Under the PLC section, I select CPU core. Let's go online. Connection established. I am switching the PLC to run mode. We have confirmed that the device has entered run mode. Now, let's write a short program. I'll add a normally open no contact into the main block. From data block 0, I'll select a bit that toggles every half second. I will then assign the Q0.0 address as the output. I go online and upload this change to the PLC. As you can see on the screen, the Q0.0 output is periodically toggling between true and false. Similarly, you can observe this physical change on the PLC 0 in the video. We could also include the input buttons on the PLC 0 in our program. I have repeated the upload. Now, the output should only activate when I press the button. Indeed, as I press the button, we can see the outputs on the PLC 0 activating both on the screen and in the video. Let's disconnect FulmaticSoft and close Visual Studio Code. Now I am launching the STM32 CubeMX application. I'll click the Other Project button and navigate to the project folder. I am opening the .ioc project file within the downloaded folder. Here you can see the project we configured for the STM32F407. We can modify the clock, analog, and all GPIO settings through this interface. Additionally, we can update pin functions as needed by clicking on them. I won't be making any changes at this moment. I'll click Generate Code to rebuild the code structure. The project has been successfully reconfigured. Closing CubeMX now. Reopening the VS Code editor. Since the folder structure remains unchanged, the project updated by CubeMX has loaded automatically. Waiting for the files to load completely. Loading is complete. I am building the project again. Our updated code has been compiled. The process finished successfully without any errors. Once again, I'm starting debug mode with F5. The project files are being flashed onto the chip. Flash complete. I'll click Run to start the system. We return to the FulmaticSoft software. We are sending our project to the chip. Now we can perform all operations online. As you can see, manufacturing your own PLC with the Fulmatic library is quite straightforward. Our processes do not involve complex licensing procedures. Simply add the relevant chip to your circuit board and activate the licenses you've purchased by assigning them to the chip via our online licensing app. You may use it without a license as long as your code size does not exceed the 2048 byte limit. There are no restrictions regarding I/O modules. We only license the PLC's CPU module. You can produce and sell as many I/O modules as you wish. Fulmatic PLCs support expansion up to 16,384 I/O points and 772 blocks. We use the OEM PLC design as our reference schematic. This design is shared on our website. You can examine the circuit schematics, Proteus drawings, and visual aids in detail on our page.